We do is some more VLAN here. VLAN tagging, trunking, nice words there, right? Native VLAN. Voice ports, we can talk about the voice VLAN and a Cisco proprietary and a standard protocol, CDP, Cisco Discovery Protocol, and LLDP, Link Layer Discovery Protocol. This one will talk about objectives 2.5 and 2.6, configure, verify, troubleshoot, inter-switch connectivity, and a configure and verify layer 2 protocols. I want to go through the PowerPoints, and after that I want to do a demo and show some of the characteristics and how to configure the VLANs and trunking, tagging, trunking, access ports, where we use each of them, how they come in handy. So with that, VLAN, we created VLANs with the VLAN command. It was pretty straightforward, VLAN and then a number, whatever we want it to be. And then we added the ports to the VLAN. In order to add a port to a VLAN, we had to make it an access port. An access port is one that has devices that access the network. End devices are going to be connected to it. And then one advantage was users in a different physical location can be on the same VLAN, the same network. And that's what this image is supposed to show here. We have the third floor, the second floor, and the first floor. Each of these individuals are in the sales VLAN. They're in the sales broadcast domain. So different broadcast domains, subnets in different locations, different physical locations. These could be on floors, these could be in buildings. Anything that we can connect together with an Ethernet, we could be that way. So we had sales here, engineering here, HR here, all on separate VLANs, separate broadcast domains, connected together here by a router. So a router allows these guys to communicate with each other. The advantage here is we can have access control lists so that we can restrict traffic at layer 3 by having our VLANs and then using a router to connect the different networks together. So VLAN is a broadcast domain, same network subnet. We provide some separation and a little bit of security there when we do that, because we can go in and create access control lists and restrict traffic at layer 3, a capability that we wouldn't have at layer 2. A trunk port is a port that allows all of the traffic, and I'm just going back, we haven't gotten it there, but allows all of the VLANs, and we said that earlier with the ones that had the little colors on it. So if I had switch here, and I had VLAN 3, VLAN 4, VLAN 3, VLAN 4, VLAN 5, doesn't really matter how many we have. These are going to be on access ports because they're going to access the network. Connecting the switches together to allow traffic from 3, 4, and 5 to get from one switch to the other is going to be a trunk port. So a trunk port carries the traffic for all of the VLANs. What we're going to do, and we have some more images here, I tend to get ahead of myself, but as we leave the switch, we're going to tag using a protocol called 802.1q to tag the frame with a VLAN number. So as it leaves the switch in the trunk port, it gets tagged 3, 4, 5. VLAN 1, the default VLAN, is also going to be what we'll call the native VLAN, which doesn't have any tags on it. We'll talk about that in a minute, why we don't do that. So as it leaves, it's tagged. As it gets to the other switch, the tag is taken off, and the traffic is that the frames are then sent to the VLAN that they were tagged for. So what we can have a manual or automatic configuration of these things. The problem with the automatic, we go down here, we may inadvertently form a trunk. If we do that, then we can get all of the VLANs. Because we have a trunk port, all the traffic from all the VLANs are on the trunk port, unless we restrict it, and we'll see how to do that too. So all the traffic from all the ports are on the VLAN, and then I have a hacker that plugs into here and adds himself to, let's say, to the payroll VLAN. So now this user, this hacker, is into my payroll network. So the disadvantage of automatic configuration is that a hacker may access any VLAN, if he can configure a trunk port on the switch, a rogue switch. And we'll look at some of the security measures of how to prevent that. So the different configurations for trunk ports: dynamic auto and two dynamic autos, and this is automatic. And what this says is, if you ask, I will become a trunk port. Dynamic desirable says I'm asking, as does the switch port mode trunk. So if these two, trunk, dynamic auto, if we have two of those, we have an access port. Dynamic auto with either a dynamic desirable or a trunk becomes an access port. If we have an access port and a dynamic auto, since the access port can't ask it to be a trunk, then it's going to remain an access port. Dynamic desirable is going to create a trunk with each of these things except an access. A trunk, when we just go in a switch port mode trunk, a static trunk is going to be a trunk, and if we have a trunk and an access limited connectivity, we're going to get erratic behavior of the port. Same thing here with access. Everything remains access unless we have a trunk and an access, and then we have again the limited connectivity in it. How does it work? This is a much prettier drawing than mine was. When we do these things, we need to mark the frames with a VLAN number. And 802.1q is the protocol. And if we go down here, what we do is insert a tag, a shim, between the source MAC and the type link. So we're going to put a shim in here. It's going to be the tag, the 802.1q, and they call it .1q in here. And the tag has got an Ethernet type, a priority, and then we have a VLAN identifier, which is going to be the VLAN number. So we have this tag in here that's put in as it leaves the switch. And again, we're back to the same colors here, and the trunk shows all the colors to indicate that all of the VLANs tagged traffic travel across this trunk. The frame is marked with the VLAN number as it leaves the switch, and at the destination the tag is stripped and the frames forward to all ports in that VLAN, so that we get traffic VLAN 1 talks to VLAN 1, 2 to 2, 3 to 3. In this case, we don't have a router, so they can't talk to each other. Special port called a trunk to forward the traffic switch to switch, all of the VLANs switch to switch using the trunk port. Handy thing to have. And the way that we create a trunk port, we can either use the dynamic back to this thing here. The easiest way is, since everything by default now is dynamic auto, you may have some older switches which would be dynamic desirable. Was the default for a long time. The problem with that is back to it asks everything else to be a trunk, so the trunks are more likely to form inadvertently. Special considerations that we have: the default VLAN we've talked about is VLAN 1. Cannot be modified. The name and the number can't be modified, can't be deleted. But as we have seen, we can move the ports from that VLAN to other VLANs. This says control traffic, and it is control traffic, and we're going to have some things that the switches communicate with each other. Use VLAN 1. Management traffic is typically going to be VLAN 1 also. We also have this other VLAN, other term called the native VLAN. Untagged traffic. The untagged traffic, what if we had a hub? Okay, hopefully we're not going to have a hub, but if we have a hub in here, it doesn't have the ability to tag the traffic. So the untagged traffic was put in for legacy equipment. Also, we may use some control traffic as untagged. And this is the native VLAN. By default, the native VLAN is the default VLAN. A lot of defaults there, but VLAN 1. We can change the untagged VLAN and should to something and has no ports on it. So that something like is here because security issue with double tagging. What we have here is the access. We access VLAN 1. We have VLAN 1, VLAN 10, access VLAN 10. VLAN 1 here is the, in this case, VLAN 1 is the native VLAN. So, and we tag it as VLAN 10. It goes across here, gets stripped off, and says, oh, VLAN 10, victim, we're going to get there. So in the double tagging, the VLAN 1 expects to be untagged, so it gets stripped off, and then we get sent to the VLAN that we're trying to attack. Just as an oh by the way, if you have a native VLAN mismatch, and we can do that, you're going to get a lot of error messages, and it's going to go into what I call error inconsistent mode and won't send traffic. So to protect against being able to do what's called VLAN hopping, we don't allow, or we warn, or Cisco warns the user if they're in a situation that could be hazardous in the native VLAN area. The voice VLAN, the only time, get my pen over here maybe, only time an access port can be a member of multiple VLANs. Uses untagged packets. IP phone, the phone itself is a 3-port switch. So we have the computer, phone, and the access switch. We plug the phone into the switch. This is going to be the RJ45 that goes to this switch. The switch is on a VLAN. Let's say it's VLAN 40, data VLAN 40. What happens when the data packet, the frame, leaves the computer? It goes to the IP phone. The IP phone does not tag it. It sends it untagged to the switch. Switch then tags the data with VLAN 40. The voice VLAN, actually we'll say 100. Actually just change that to 40. The voice VLAN is VLAN 150. The phone tags the voice packets with as VLAN 150 tag, 150 VLAN. Goes into the switch. The switch then doesn't bother them because we have created a voice VLAN, a special VLAN. And this is the one case where a port and access port can be a member of 2 VLANs, the data VLAN and the voice VLAN. So we separate these, and we do want to separate the voice from the data traffic. Sniffing for one thing, and also separate broadcast domains, separate traffic, get some isolation at layer 3. Computer packets are untagged by the phone. That tags the voice packets, the phone does. The access switch tags the data packets and achieves separation of voice and data, which we want to do so that we have the isolations that we talked about. CDP, Cisco Discovery Protocol, is a Cisco proprietary, and we're going to have what we're going to find out a lot of times is Cisco does something, makes it a proprietary protocol, and then a little bit later we get a standard, which is going to be the next one, LLDP, that enables us to do certain things. So what this does, and CDP is enabled by default. Gather information about directly connected Cisco devices. CDP advertisements contain the type of device, the interface, used to make the connection, the model number of the device, and has a detail switch. Detects layer 2 and layer 3 devices and uses the native VLAN, the untagged VLAN, in order to do this. I was going to do a demo on VLANs, but right now I think that I'd like to do a demo, and I've got a couple of different arrangements here. Let's just go into here and turn this. It's on by default. We can turn it off. And so enable, and let's show CDP neighbors. When I do that, I have a switch and I'm connected on gig 01. I have a hold time here. Capability here is a switch. Platform is a 2960. Tells me what kind of switch it is. And then the port at the other end, both of these are on gig 01. If I wanted to get more information, I could show CDP neighbors and then do a detail. I could look at use the question mark and see what's there, and detail is the only modifier. A little bit more information about it. Detail, switch entry, it's a 2960, and on down the line. It tells me what version of the software it's running. And then we're in the advertisement version 2, and we're a full duplex. The other thing that we can do up here, I got some more devices. If I go to this switch, and these are for directly connected devices, layer 2 connected devices. CDP neighbors, again I just have one, but this time I have the router. I have a C2900 router. If I show CDP neighbors detail, I get the IP address of that router along with the ports and all the other information that's available on it. It is also CDP. I'll go to the router here and show CDP neighbors, and it also has that capability. These are the two switches that are connected to it. So what we have here is a layer 3 device and a layer 2 device. CDP is a layer 2 protocol, Cisco proprietary protocol that gives us information about directly connected devices. We can turn it off on the entire switch with the our router with the no CDP run, enable or disable CDP. And when we do Cisco, we do the command to turn it on, and typically we're going to do no to turn it off. And let's go to interface gig 00, no CDP. In this case, no CDP enable. So you run it on the device, turn it on and off on the device, enable or disable it on an interface. Sounds like a dangerous thing. Can be a dangerous thing on your own network, probably not. And if you use Cisco IP phones, you really need CDP for the telephones to get their configuration information. The no CDP enable, you probably want to disable it on the port that, let's say, goes to your ISP, so that you're not advertising or allowing them to see what's connected directly to them. The LLDP is the industry standard to discover Cisco and non-Cisco devices. Layer 2 protocol, queried with SNMP, Simple Network Management Protocol. The TLVs, the information, system description capabilities, device identity, port description, port VLAN, and configuration information. Very similar to what we've seen with the CDP information. So in this module, we talked about a VLAN as a broadcast domain, which I've talked about several times. It's the same as a local area network. We just configure it electronically instead of physically. Configure the VLAN. We talked about the special VLAN would being the voice VLAN, and how the configured the auto, desirable, and trunks. How we create trunks and in the devices. And then we looked at CDP, the Cisco Discovery Protocol, Cisco Proprietary, and LLDP, which is the standard that does the same thing as the CDP protocol. I want to do a demo of VLANs and kind of how they work and what can and can't happen in them. I'll see you there.